Hello. In this video, we're going to go through an example of how to factor a trinomial using decomposition when a is not equal to 1. Decomposition is a very algorithmic approach, meaning if you follow these steps, it will always work. We do want to eventually get to a point where we can factor most trinomials using inspection. However, decomposition is a wonderful tool to use when you're first learning. So let's take a look, shall we? So I take a look at this first one, and before I try and apply a trinomial factoring technique, I always look for common factors. So I'm going to look at the three terms here and look for any common factors there, and there isn't any. So that means I can't factor out some common factor. The reason I do this is because it makes the trinomial factoring a lot easier. So we can dive right in. So the first thing I do is I write down my A, B, and C terms. So A is 1, B is 8, and C is 4. And then what I do is I figure out what's called the product. And the product is the A times the C term. So the product is going to be 3 times 4, which is 12. And the sum is the B term, which in this case is 8. So now I say to myself, two numbers that multiply to 12 and add to 8. Now, when I go through this thought process, there's lots of little tricks and patterns to look for, but the first thing I notice is that the product is positive and the sum is positive, so I know my two numbers have to be positive. And with a little bit of, you can write down some tables, so I can say 12. Well, what two numbers multiply to give me 12? Well, 12 times 1 is equal to 12, but 12 plus 1 is equal to 13, so that's not it. Well, what about 6 times 2? 6 times 2 is equal to 12, and 6 plus 2 is equal to 8. Perfect. So my two numbers are 6 and 2. So what I then do is I take my trinomial and I decompose the middle term, the b term. So I get 3x squared plus 6x plus 2x plus 4. This is why it's called decomposition. The 8x is decomposing into 6x plus 2x. I haven't actually changed what this expression is. I've just changed how it looks. So then what I do is a neat little trick here is that if I take the first two terms and I factor out the common elements, and then I take the second two terms and factor out the common elements, a neat little pattern emerges. So in the first two, I can factor out a 3x. So I'm going to say 3x, and that's going to leave me with x plus 2. And then the second two terms, I'm going to factor out 2, and that's going to leave me with x plus 2. And this is why I love math, because now I have a built-in little check. And I actually put check marks here when I'm checking my work, that if I've done this correctly, these two binomials should be the same. So then what I do is I say, well, now I have this binomial here and this binomial here. I can factor that out. So I end up with x plus 2 times 3x plus 2. And now I have factored this trinomial using decomposition. Let's look at a second example. So this example, I might look at it, and initially I might be a little overwhelmed because negative 6 times 12, that's going to be a pretty big number, negative 21. But again, remember what I said before. Let's change our colors actually. The first thing you always want to do when you're trying to factor a trinomial is look for a common factor. And sure enough, I can notice here that I can actually factor out of each of these negative 3. Now the reason why I factor out negative 3 and not just 3 is I like the leading coefficient to be positive. So therefore we're going to be left with 2x squared plus 7x, almost made a mistake, minus 4. So now I'm ready to go and factor this. So therefore, what I can say is my A is equal to 2, my B is equal to 7, and my C is equal to minus 4. So therefore, my product is negative 8, and my sum is equal to 7. So now I say to myself, I need two numbers, and the product has to be negative 8, and the sum has to be 7. Well, a nice little some patterning happens here with the signs. Well, if two numbers multiply to give me a negative, that means that one of the numbers has to be a positive and one of them has to be a negative. If the sum is 7, which is a positive, that means that the larger number has to be positive and the smaller number has to be negative. So what I'm going to try here is let's try 8 and minus 1. So 8 times minus 1, sure enough, is negative 8. And 8 plus minus 1 is 7. So that works. So therefore, I'm going to decompose this. Negative 3 bracket 2x squared plus 8x minus x minus 4. And notice I didn't get rid of that minus 3 there. Minus 3 bracket. Now I'm going to factor out 2x from the first two. And if it helps, if you underline these, some people find it helps. You know, anything that helps you kind of see what you're doing and avoid making careless mistakes is good. So they're going to get x plus 4. And now I see here I have minus x and minus 4. So the question is, what can I factor out of that to get x plus 4? And that's minus 1. And so we get x plus 4. And now I have my feel-good moment because those are the same. Those binomials match. So what I can then do is factor those binomials out. Negative 3 bracket x plus 4, 2x minus 1. And now what you might notice here is that this bracket here and this bracket here are actually redundant, meaning they're extra. I don't need them. So I would actually write this out as negative 3 bracket x plus 4 times 2x minus 1. And of course, the great thing about these types of questions is that you can always, if you have time, is check if you got it right by simply expanding each of them. And if you expand them, you should get back to the beginning. So that's how you use decomposition to factor trinomials when a is not equal to 1. Great technique, it will always work. But remember, we want to start moving towards the ability to do these by inspection, because by doing that, you're going to become a lot faster and more complicated questions become more accessible. I hope this helped.